Okay, good morning, all of you. I'm audible. Can anyone please confirm?
Yes, Vida.
Okay, so let me share my
Vida,
screen.
Vida, 2 minutes, Vida. Just two
Yeah, sure,
minutes.
sure, sure.
Veera, I think you can start.
Yeah, sure. Okay, let me share my screen. So I think if you are having any questions on Docker, you can ask so that we can proceed for Kubernetes today. The Kubernetes. So Kubernetes is very important tool as a DevOps engineers. So actually in the real time, once we build a Docker file, the image will come. That image we can push into ECR or Docker Hub registry. So the Kubernetes input is either ECR or Docker Hub registry. So whenever build a Docker file, so we can generate an image. That image we can push in ECR or Docker Private Hub registry. So now, what is Kubernetes? Just we'll understand in very high level today. So first of all, Kubernetes is a Kubernetes is orchestration tool. Okay, Kubernetes is orchestration tool. Okay, so which orchestration it is? Container orchestration. Kubernetes is container orchestration tool. So orchestration is nothing but here. For example, my end, one EC2 instance is there, and on top of the EC2 instance, so this is hardware, and this is OS. So if you install Docker here, so number of containers we can create: container 1, container 2, container 3, container 4, container 5, 6, 7, right? So this container orchestration, when in Kubernetes, in terms of Kubernetes, we can call these are not containers, these are pods, PODs. So pod is similar to container, but if you run Docker run command from the image, so Docker run image, okay. So if you run this command, container will be created. So here container will be created by using Docker run command, okay. And but whenever you can run the image, container will be created. So if you run from the same image, instead of Docker run, so if you run like a kubectl apply -f and Kubernetes YAML file. So here pod will be created, not container. So the difference is here from from the same image reference, if you run through Docker run, container will be created. If you run through kubectl, I mean Kubernetes, pod will be created, but both are same. So pod is nothing but on top of the container, we have a one more layer. Okay, anyway, we'll discuss later. So these are the pods. So what we can understand here, these pods are orchestration. So each pod having one application. So each pod having one application. Like that, just understand here. These pods are related to different application. This pod may be, so this pod may be related to one application, this pod may be related to one application, or this pod may be two pods are running for the same application, replicas. So this entire orchestration, when the new pod will be created, when the new pod will be modified, when the pod will be deleted, how many pods will come here, how many pods required here, as per the replica. So we can use Kubernetes concept. For example, for example, so here, yeah, so here, this is node. Node is nothing but EC2 instance. So I need to deploy my Flipkart image. For example, my end Flipkart image is there. So this Flipkart image created from Flipkart Docker file. So this image you can push into ECR. Let me take a flow. So developers develop the Flipkart application. Excuse me. Flipkart. So Flipkart application developed by developers. So what we need to do, this application, they push into GitHub remote repository. And then what you need to do here, this is Git. So from here, we can write a Docker file. And copy the source code. It's Docker file. So Dockerizing process, application Dockerizing. Application Dockerizing. Okay. Application Dockerizing. Okay. Application containerizing. So this Docker file, whenever you can build here, so we'll get a one image. So this image we can push in ECR or Docker private registry. So build and push. Okay, build and push. So image will be created here. So this image, if you run, container will be created. But how to orchestrate this container? We have a Docker Swarm. So if I go for Docker Swarm process here, I will share this Docker document to you. So Docker Swarm is a container orchestration tool for clustering and scheduling the Docker containers with Swarm. So here developer can establish the manage the cluster of Docker nodes, a single virtual system. Docker Swarm lets developers join multiple physical virtual machine into the cluster. So Docker Swarm not supports auto scaling concept, but Kubernetes will support. So Kubernetes advantages, it has a large open source community backend by Google. It supports every operating system. It can sustain and manage large orchestration and complex workloads. It is automated and has a self-healing capacity, supports auto scaling. It has a built-in monitoring and wide range of integration availabilities. So whatever we have a, so it's offer all three key cloud providers, Google, Azure, and AWS. So that's what we are learning here, Kubernetes instead of Docker Swarm. Both are orchestration tool. So now, okay, my image is ready now. So whenever if you run this image by using Docker run, if you're in Docker run, containers will be created. But I'm not going to create a containers and I need a pods. I need a pod. In this case, what you need to do here, Kubernetes is taking care. So this is Kubernetes here. So here Kubernetes is taking care. For example, this is your ESOT instance deployment. Uh, Whenever you run a container will be run in your ESOT instance, right? But here, whenever you execute this image through Kubernetes, container will be created inside your server. Now Kubernetes will decide how many containers are required for this application. So here Flipkart. So Flipkart container or pod both are same. Almost 99% same. I will show you the differences here. Flipkart. So this is two pods, replicas. If one pod will down, we can get one more pod. And for example, Kubernetes is also taking care of node high availability. So here Kubernetes taking care orchestration of node high availability. For example, if you want to create 4 containers, Kubernetes automatically will create, sorry, 4 pods. Kubernetes automatically will create 2 pods in one node, 2 pods in one node like this. Here also Flipkart. So here, if one container, one pod will down, no problem. One more pod will be here taking care. Even one node will down, no problem. One more node is taking care here. So node high availability, pod high availability. Node HA, pod HA, taking care by Kubernetes. So orchestration, and here, if you can see, 2 pods are running in one node, 2 pods are running one node. So Kubernetes is orchestrate here where pods are going to be executed, when the pods are going to be executed. If something is wrong here, how the pods will be taken care. Everything we can understand here. Okay. So now, yeah. So now here, yeah. So here one pod may down here. So one more pod will work. 2 pods may down. Two more pods will work. I mean, in the auto scaling concepts, if I create a multiple ESOT instances by scaling, so 1, 2, 3, 4, Whenever the traffic will increase, automatically auto scaling group has increased the low. I mean, auto scaling group has to increase the servers count as per the traffic, right? But at that time, we have already discussed the servers is nothing but EC2 instances. But in this process, not servers, these are pods like a containers. So each pod having same application. Here, four replicas are there, means four pods are running for the same application. So if you compare with this process with the auto scaling group, okay, maybe four replicas. So four instances count. If one instance may down, one more instance will work. So like that, it is taken care by Kubernetes. So here Kubernetes, if you can take here, taking care by node high availability, pod high availability. How many pods required for this image application to give a high availability, to manage the traffic? How many pods required? Everything taking care by this orchestration is taken care by Kubernetes. Okay. So how to define Kubernetes? So Kubernetes define in AML file only. So YML file. So here, so the deployments we can written in AML language. So the deployments we can written in AML languages. Okay. So this Kubernetes supports AML file. So here we can, deploy, we can write in any AML deployments, we can written in AML languages. So what is deployment and all we can discuss. So the deployment is nothing but our source is image. From this image, let me show you here. For example, sample deployment for my Kubernetes, I will show you here. Yeah, if you go for worker node components, deployment at YAML, see here, I'm going to create so everything, the deployment model, we have to develop in YAML language. So if you can see, this is the image. Source has an image for this YAML file. Where is source entry? Here the image entry. This image is what Nginx. But in our real time, this is just public image I'm taking. The focus is on development. So we can give our image path here. Our image path means our image already stored in ECR or Docker private register, right? So we have to take that path. We have to mention here. And then these are for other specifications. If you can say replica equal to 3, whenever I can deploy this deployment by using Kubernetes, 3 pods will be created for Nginx image. If it is a Flipkart image, 3 pods will be created for Flipkart image. If it is a Swiggy image, 3 pods will be created for Swiggy image, like that. So before need to be run this YAML file, ensure your image should be created, your image should be pushed in ECR, so that next stage will come Kubernetes deployment. So Kubernetes deployment, we have entries here 3, 4, 5. So also we have a dynamic scaling process also we have in Kubernetes especially. So we'll discuss later, but the deployment is YAML language, which will support the Kubernetes is taking care of everything with this YAML file only. So now, okay. So this is the process, what we can understand from here. So, and these are the advantages. I want to discuss my Kubernetes advantages. Kubernetes developed by Google only and a large open source community, free of cost, not required any, no need to pay any, enterprise version and all. It is completely free of cost. So especially it's well suitable for large architectures. For example, 1,000 containers, 1,000 applications, hundreds of applications. If you want to deploy, so hundreds of applications, we need hundreds of pods. The orchestration is taken care by Kubernetes. For 100, for example, 100 applications, if you want to deploy 100 EC2 instances, the job is very difficult to manage and all, right? So that's what here is So job is very easy to orchestration and all by using Kubernetes. So any questions for this introduction? So any question, the very high level understanding of Kubernetes?
Veera, please can you explain what is node and everything in some
Uh,
detail?
yeah, we'll discuss later. Just what I'm saying here. Yeah. So if I take a node is nothing but what here? EC2 instance only. Here two EC2 instances are there. Okay, two EC2 instances. For example, in the Docker concept, on top of my EC2 instance, if I install Docker, I can create multiple containers right here. So same concept here, but instead of Docker, so we are creating a containers through Kubernetes. Whenever you can create a containers through Kubernetes, this naming as a pod, not container. So nodes are nothing but here EC2 instances only. Where exactly your pods are running? These are nodes. So how many nodes required? Completely Kubernetes is taking care. One node, see, one node will support. If I take a one node hardware is a 16 TB hardware is a maximum size of, sorry, 16 TB hard disk is the max size of your EC2 instances. If I can take a 16 TB, I can create 1 lakh 16,000 change pods on one EC2 instances. The minimum size, the minimum average size, I'm saying that. So each pod one application means you can deploy 1 lakh applications on only one EC2 instance. But that 1 lakh applications, how to orchestrate? I mean, which application is going to give access for public, which application is going to access for private, which application need multiple replicas, which application need only single pod. Like that, these are comes under orchestration. That is everything taken care by Kubernetes only. Okay. So finally, our deployments on in EC2 instance only. For example, if you are not containerization process, what will happen? Each application you need to deploy one EC2 instance. 100 applications, we need to deploy 100 EC2 instances. But here, no need to create 100 servers. One server even fine to deploy 100 applications if you containerize the process. Okay, if I containerize the process, how to orchestrate the process? You can take a help from Kubernetes. Okay, how many EC2 instances required? So for example, if 10 applications, if you're deploying 10 pods are required, right? But 10 pods are not sufficient for to manage the high traffic. So we need to create a multiple pods, like a multiple containers, like a multiple EC2 instances. So multiple pods has to create in same node, I mean same EC2 instance or a different EC2 instance. If you need a node high availability, whenever 10 pods are running in one node, entire node may be deleted. What will happen? Entire pods will be deleted. So instead of that, so we can achieve node high availability. So create a two nodes, create 5 pods on one node, 5 pods on one node, instead of creating 10 pods in one node, like a node high availability. Clear? How Kubernetes is going to taking creating and all we'll discuss later. So this
It's
is very
clear.
yeah, this is very high level and understanding process. Yeah, let me take now. So the very important concept in Kubernetes, the architecture is very important. How Kubernetes will work. So in Kubernetes, we have a two type of nodes. Okay, we have a two type of nodes. One is control node, and other is worker nodes. So this Architecture is a little complex. Try to understand here how to interact with Kubernetes. So tomorrow I will show you the creation of cluster and all. So I'm going to create it. This is my laptop. So I'm going to deploy. I'm giving a one requirement is from here. I'm going to create a pod. So I'm going to create a basic pod.yaml. Pod is nothing but what? It's kind of container. I will show you here. Here pod is nothing but what? So pod is nothing but it's like a container. So whenever you can create a container, on top of that one more layer is added. If you deploy, if you create a image from the Kubernetes, that layer is called pod layer. Abstraction layer of on top of the container is nothing but pod. This is container. Container creates from so container inside application is there. Application created from the container. So application created from image. So this is the layers. This is image. So whenever you can create a Docker run from the image, so this application in the form of image, so container will be created. This container inside application will run. This application is created from this image, but this container runs inside the pod. This is called pod. Here pod is nothing but abstraction layer of on top of the container is called. Okay, so this pod can run on inside the node only. Node is nothing but EC2 instance. So here, if you can see, this pod will create from the YAML file. So Kubernetes will support only YAML files, right? So if I go to here, take the sample pod.yaml here. This is sample YAML file. We'll discuss tomorrow the YAML files in depth. So this is pod.yaml. So whenever run this pod.yaml, so Kubernetes will create a pod inside of the worker node. So one pod will be created here or here. So how the system will work, we can discuss one by one now. So Kubernetes supports two kind of nodes, two type of nodes. So one is control node or control plane, and other is worker node. Here actually pods will deploy in worker nodes only, not control node. Okay. So these are worker nodes. I mean EC2 instances. Worker node 1. So we'll get one entry question on only architecture, guys. Only architecture. They can ask any one of the components how it will work. So on that only components, we'll get one entry question, definitely. EC2. This one also EC2. Okay. Now here in the Kubernetes control plane, this is control plane. Control plane control the worker nodes. Control plane or control node, both are same. Here control plane controls the worker node. So here control node control the worker node operations. So worker node host the pods. Okay. So in this case, how the system will work, we can discuss. In the Kubernetes architecture, in the control plane, the very first important component is API server. So this API server only interact from your your developer or user. So for example, I need a laptop or EC2 instance. So I'm going to create this pod.ml. We have a command in Kubernetes kubectl apply -f pod.ml. So if you run this command, one pod will be created where on worker node. So one pod will be created here, worker node. But this is not at all easy task to create a one pod and worker node. That is taking care of anyway, the Kubernetes. So how the request will go? Whenever Docker command you can run, the Docker command client commands can execute in the Docker host. So the request will go to Docker daemon. Docker daemon is taking care of the controller, like create a pull the image, base image, or whatever the actions it is taking care by Docker daemon. Here Kubernetes is taking care everything. So the request will go to first API. We have a API server here inside the Kubernetes control node. This API server interact from the user. Okay, we will write everything in one word definitions after complete the components explanation. Here this API server interact from user and cluster mainly. So whenever user can give any execution commands, the request will go to first API server in the control node. So okay, so I got a request from a user. This user is going to create a one pod with help of Nginx image. This is public image or private image or whatever image. This image or custom image. If you write a Docker file, if you build a Docker file, one image will be generated. That image we can push an ECR or Docker Hub registry. So we can give that path here. One pod will be created for your with your application. That pod you can give access to public. They can connect to your application like a server and container. But the important factor is, so, okay, my request has to go API server. API server will check with next component. So we have a next component is etcd. etcd. So etcd is a kind of database, kind of database only. It can where we can store the all configuration details. For example, this pod already created a node 2. Immediately this information API will give to etcd. You can store the pod information. The pod is running on node 2, the configuration and all. Like this, etcd will be host the all configuration details. So what will happen here? Whenever API, okay, whenever API receives the request from the user, create a one pod, API will check with etcd first. Okay, so user is going to create a one pod. So this information go to API server. API server will check with etcd. Do you have any information on this pod in your end? So this is old pod or new pod? I mean, just now deleted pod so that we can create pod in the same node, or this is new requirement. Whenever API server will ask with etcd, etcd will verify with this pod details. So etcd will give back to the response to API my and no details. So etcd and no details are there means, so I think etcd stores all the pods information, configuration information. If etcd and there is no any information regarding this pod.ml, so API can understand, okay, this is maybe new requirement from the user. That's what we don't have any information. We don't have any history respect to pod. Okay, now again, if API server will send this request to one more component. This is very important component. Is a scheduler. So this mode, so it will ask to scheduler. API server will request the scheduler. So it will ask like, so we got a one pod creation requirement from the user. So here scheduler will taking care of schedule the pod on specific node where this pod has to schedule. For example, so my end I'm able to see here two nodes. So whenever you can create a Kubernetes cluster, at least minimum you have to create two nodes, two EC2 instances. In this case, here there is some ambiguity. Okay, the pod requirement is one, right? So where exactly this pod has to schedule, that is taking care by scheduler. So whenever API will ask, I'm getting a response from the user has to create a one pod, where exactly this pod has to create. So scheduler will verify with the resource details. For example, this resource already busy with more pods. This node already busy with more pods. It's taking more resources from hardware. This node has less pods. We have a enough space on the hardware. So scheduler will verify the resources and it will decide where exactly pod has to be created. So scheduler will give a back to API. Okay, we can create a pod in worker node 1. Okay, API will take the information for scheduler and again it will give back to etcd. Okay, I'm going to create a pod in node 1. You can store the configuration data. You can store this information in your end so that if pod will be deleted, again we can create a pod in same node with your stored information. Okay, again API will check with etcd. Etcd will give back to API. Okay, noted the request. And then API is decided, scheduler has decided where exactly this pod has to be created. Now, so API will interact with the worker node with this all information. So API can interact with the worker node here. In API end, we have a kubelet component. So this kubelet component is very important component. So it is the main component in the worker node. Okay, this is the main component in the worker node to take the information from the control node. So kubelet will receive the information from the API. Now API and having information where exactly this pod has to be created with help of scheduler. Now API is saying that I have received the request from the user to create a pod. My scheduler is decided to schedule on worker node 1 only. So your end, you can create this pod. Okay, whenever receive the information from the API, our kubelet will run the container runtime. Docker container runtime. So whenever I can create a Docker container runtime with help of kubelet, so one pod will be created. So one pod will be created in this node. This is a process will work the background, and we have a few more components we'll discuss. And this pod has to give the access to public or anyway. We have to give this pod inside application is there, right? I have to give this pod access to public or anyone. So in this case, we have a kube proxy component will help to create a network inside worker node component. So this kube proxy help to create a network inside the worker node to give access to public. For example, here is the user. So user can access this pod with help of kube proxy. So here service will be created, load balancer or something. This service will create with help of kube proxy only. So these are the main components. Whenever pod has created, immediately kubelet will give information back to again pod has scheduled to API server. And the API will again give information etcd. We have created a pod in this node. You can note it in your end. So etcd will store this information into etcd. Sorry, yeah, etcd will store the information into pod details. So this is the process will run the background whenever you can create a cluster and worker node components. So here entire this process is called cluster. This is entire is calling cluster. Cluster is nothing but combination of worker node and control node. So now we can discuss in detail like a single line flow. Yeah. So this is worker node component one. So if this case my and two nodes are there, same setup is there in worker node 2 also. So user can access like this. So this is the process will run the background. So whenever pod will be created, so inside image is there, application will be created, container on top of the pod will be there. So this is the process, the background. Let me show you now one by one process. So this is actually whatever we discussed that architecture. Here's one thing is missing. This is control manager. So let me write a control manager also now here. So controller. The purpose of the controller is here. So whenever pod has created, always this controller will manage the desired state and current state. What is desired state and current state? For example, my deployment.yaml. So if you can see my deployment.yaml, 3 replicas has to be created, right? Always it should be maintained 3. If you delete if you delete any one of the pod from the out of these 3 pods, again one more pod will be created. I mean, this state has to maintain 3 pods. How this will work? With the help of this controller only. The controller job is here to manage desired state is equal to current state. So my pod only this is pod.yaml. That's what one pod is created. If it is a deployment.yaml, 3 pods has to created. So controller always maintain 3 pods in worker nodes. If any one of the pod will be deleted, immediately controller again create one more pod with the help of API. I mean, any pod will be deleted inside the control worker node. Immediately API receives the information from the kubelet. One pod has deleted here. So immediately API will give the information to a controller. See, one pod has deleted now. So immediately controller check with the controller check with the desired state of your YAML file so that immediately it is maintained to the current state. So deleted pod again is going to be created. So controller has to take care, like a Terraform state file, maintain the desired state and the current state. So let me show you the process now in different way. So definitely we'll get a better clarity with that. So one more time, whenever user has to be created, so the request will go to the API. API check with etcd. Any information is there regarding this user request. If nothing is there, API server can understand this is new requirement, creating pod. So it will check with scheduler. Scheduler will decide where exactly this pod has to be created and given back to API server. And API server check with kubelet. So one pod has to be created on specific node. Okay, kubelet will create a container on specific node. So whenever the pod will be created, the background service proxy is help to kube proxy or service proxy help to give this access, this pod access into the outside by using this proxy only. So when after that, this kubelet give information back to API server, created a pod. API given back to control manager and its CD. So control manager always watch desired state and the control current state. If anything is deleted, take the help from API server. Okay, one pod has to be deleted. So API server inform to control manager. A control manager, one pod has to be deleted in worker node. So immediately you can maintain the desired state equal to current state. So control manager again created again run a kubectl apply if the background. So deleted pod it has to be created immediately. So this is the process we work. So this is single line diagram. The pattern extensively used in Kubernetes. For example, when you create a pod using kubectl, this what happens. So create a pod. The request first go to API server. API server write the information into etcd. So I got a requirement from the user. Any information is there in your end. It will give back to API server whether information is there or not. And then again, if information is not there, okay, then we need to create a new pod request. This is so API server will create a will ping to the scheduler. Scheduler, we got a requirement from the user. So I'm going to create a pod, which node it is available. So scheduler will given a back to API server. You can go ahead something node. Okay. And with this information, again given to CD, we got information from the scheduler need to create a pod in second node. Just make a note your in of as you are maintaining all the configuration details. Okay. Then immediately, API server take the information from the scheduler and given back to its CD, note your end. Okay, then API server with help of scheduler, whatever is confirmed, the pod has to be created on specific node, right? API server will inform to kubelet. Kubelet, we got information from the user to create a one pod and node. So scheduler already decided where exactly this pod has to be created. That's what I ping you. So kubelets will be different node to node. For example, two nodes are there. This kubelet is separate for this node one. This kubelet is separate for node two. When the scheduler is decided to where exactly the pod has to be created, API will ping the respective worker node kubelet only, not for other node kubelet. So whenever the request will come from the API scheduler, API server will create a pod with help of kubelet. So whenever kubelet get the response from the API server, kubelet will run the Docker run. So whenever run the Docker runtime, so pod will be created here. Again, kubelet will take the information, updated pod status and given back to a API server. So API server, as per your request, I have created a pod and space in my node. So this is the information. After create a pod, immediately API server will give the information to etcd. So etcd pod has successfully created as you are maintaining the configuration storage, right? So please note a event pod has running on this specific node. Okay. And etcd will give back to API server. Okay, noted your request. And this is a process. Kubectl writes to API server. API server validate the request and persist to etcd. Etcd notifies back to API server. API server again tell to scheduler. Scheduler decided where to run pod on the return to that API server. API server again give to etcd and etcd notify back to API server. Okay, noted. And again API server ping to kubelet. The specific pod has to be created on your node. Okay, kubelet run to run Docker runtime and again kubelet give back to API server, created a pod, and again API server write to etcd. Whatever we discussed just now, this is the process. So this is the architecture. Whatever we discussed now. So control plane, etcd we have control manager, scheduler, kube API server. It is interact with kubelets only. So clear? Any questions here? So yes, I can understand. This is very little difficult to understand the process. When we can do some practicals, we'll get a better clarity. Any questions?
Veera, I have a question.
Yeah,
Yeah, what if etcd says like pod is already exist?
etcd is the just store the information related to pod and node, where exactly pod has running. For example, my pod has deleted now. So earlier the pod is running on worker node 1. So immediately new pod has to be created, same worker node 1. How the Kubernetes can understand with the help of etcd only. So whenever create a pod, API server by default it will check with etcd. So one pod has deleted. Is there any information with you? Yes, the pod before delete this pod, the pod running in the specific node only. Then we can create a pod in same node only with help of etcd. So if etcd is not given information, scheduler may confuse the pod will be created any one of the node, but pod has to create in the same node where exactly it is deleted. Same node has to be created in the same pod. That's what etcd will give the information.
Okay, Veera, thank you.
But about others?
Got it.
Okay. So guys, here we need to understand one thing. We have a Kubernetes. We are going to learn here cloud managed Kubernetes in real time also. In real time also, only 95% projects on cloud managed Kubernetes only. What is cloud managed Kubernetes? So we have a AWS managed Kubernetes that is called AWS EKS. So Elastic Kubernetes Service. Elastic Kubernetes Service. And next is Azure AKS. So same Azure Kubernetes Service. And next is GKE. Okay, so GCP from the Google AKS. I mean Google GKE. So Google Kubernetes Engine. Okay, Google Kubernetes Engine GKE. EKS, AKS, GKE. Okay, so now we are going to focus AWS managed EKS. So if you know EKS, for example, so AKS, EKS, GKE 95% same. If you know EKS, AKS and GKE. Same commands will execute inside AKS and GKE also. The difference is cluster creation process. Creation of cluster in AWS, we are following EKS. Elastic Kubernetes Service is nothing but, so whenever you can create a AWS EKS, the background cluster will be created along with control node and worker node. Same Azure also. The creation of Azure AKS, the process is different. The creation of Google GKE, the process is different. But once we create a cluster, all commands will be executable inside even any cloud, AKS or EKS, GKE. The commands, whatever commands is going to be executable inside the cluster, all are same. So, and very good thing is here, whenever you can work with cloud manager Kubernetes, this control node everything taken care by AWS. Even whenever you can create a EKS, we are able to see only worker nodes. Control node is taken care by AWS. Even we are unable to see control node also. Whenever you can give any instruction from external, the instructions will go to control node. Control node will perform the actions into worker nodes. So we are unable to see these components. The background, how it will work with this process only. So always the work is 95% on worker node only. The reason our pods has to be created, pods has to be run inside worker node only, not in control node. Our deployments and everything is there inside worker node only, not in control node. Okay. So any questions? Any questions here? So here first
No.
if you don't have any questions, the first component is API, right? API is interaction between user and cluster. Our next component is etcd, stores cluster configuration details. I mean, which pod is running on which node. Configuration details, not application details. And next is what? Scheduler. So scheduler schedule the pod on which node as per availability of the node. And next is, so you will get clarity tomorrow once we create a cluster. And controller. These are worker controller. Maintain desired state and current state. These are controller components. And worker node component, first is kubelet. So kubelet is a main component inside worker node. And receives the info from API. And run the container runtime. And next, yeah, what is container runtime? Create a pod. Container run. It will create a pod. So what is kube proxy? Help to give access is pod to external. So with help of network will be created inside cluster. So these are the components of Kubernetes. So I will share this. I will share you this document. You just focus till here only, not all the stages here. Yeah, you just focus till here only. Okay, till 6 pages only. Just ignore seventh and all. So till 6 pages you can focus so that we can easily understand. So any questions?
It's clear, Vira.
Yeah, if you can see here PPT, you will get a clarity even. The first one is API server. When you interact with your Kubernetes cluster using kubectl command line interface, you are actually communicating with the master API server component. The API server is the only Kubernetes component that connected to etcd. All other components must go through API server to work with cluster state only. I mean, so no components will directly communicate here. etcd to scheduler, controller to scheduler. Each and every request has to go through API only. API to scheduler, API to etcd, API to controller, like that only. And etcd. Etcd is a distributed consistent key value stored user configuration management, service discovery, and coordinating distribution work. When it comes the Kubernetes etcd reliably store the configuration data of the Kubernetes cluster representing state of the cluster, what node exists in the cluster, what pod should be running, which node they are running on, everything. And next is controller. Basically, controller watch the state of the cluster through API server, watch future and get notified. It makes the necessary changes attempting to move the current state towards the desired state. My nodes replicas are, for example, my pod replicas are 3. If any one of the pod has to be deleted on the node. So desired state is 3, but current state is 2 only, right? Pod has deleted. Immediately it's notified back to controller through API. Okay, controller immediately created one more pod to balance the desired state 3 into the control node 3. Sorry, current state 3. What is scheduler? Scheduler watches the unscheduled pods and binds on them into node via binding pod sub resources API. So simply we can understand here, scheduler is schedule the pod in specific node only. And a kube proxy is a network proxy that runs on each node Kubernetes cluster. It's a responsible for maintaining the network connectivity between services and pods. This is kube proxy. So just go through this document. If you are having any questions, do let me know tomorrow. We'll explain in detail. Clear? Or any questions?
Clear, Vira.
Clear, Veera.
Okay, thank you so much. So in tomorrow class, we will create a sample cluster in AWS. So we can see how the interactions will work and all. We can deploy sample pod.aml. Then we can discuss what are the components are there in worker node, AML files and all. You will get clarity in 2 days, everything. Okay. Okay, guys, thank you so much. This is just for a very high level introduction. So from tomorrow, we can discuss everything in detail. Thank you so much. Bye bye. Let me share this document to you. Okay. Thank
Thank you.
you.
Thank you, Vira.
Yeah. Bye.
Veera also shared the paid notes with us.